This is not specifically ham radio, but when I got done with the project, I thought, hey, I can use this in the shack, and maybe some other guys would be interested too. So basically, this is remote switching with the Raspberry Pi, and it came about because I had a situation at work that I needed to resolve. And essentially, we had 5 different locations outside of the building that we needed to be able to, from the external locations, switch something in our studio. So we started looking around, at all the commercial gear that's available, and it was really expensive, and I needed it to be stupid-proof too. And so the solutions were really complicated, and what we needed to do basically was just toggle 5 different double pole switches. That's all. And so one of the guys said, hey, have you ever seen these little deals where you, from your cell phone, you can turn your light on in the house? And I said, yeah. Then it got me thinking, I know how to do this now. Not exactly, but I knew the direction to go. So essentially, what I want to show you here.
Black magic.
Yeah, black magic. This is kind of an overall block of the switching in our studio. It centers around this video hub that's got 40 ins and 40 outs. And video is no longer analog. It runs around on a 75 ohm cable, and they call it SDI. And it can be standard definition, high definition, 4K, whatever. But anyway, we had these external inputs coming in that we converted to SDI and inputted into our hub, and we needed to be able to switch them right before they went back out to the Comcast modulators. And so we came up with this little deal, we call it a web switch. And this basically is going to allow us to switch between these outputs and these outputs here. So the solution we came up with was to take a Raspberry Pi and configure it as a web server, which I'm going to show you is really easy to do. I mean, it's like uber easy. I was amazed I was able to get it to work as easily as it. And anyway, there are a number of I.O. ports on your Raspberry Pi, which are real easy to get to. And in this particular solution, I took actually 6. I'm showing 5 here. And I feed them over to a little interface board, which I'll discuss. And that interface board is nothing but a buffer to isolate the Raspberry Pi from the hardware that follows. And then some little relay boards, which are nothing more than low power relays that we're going to toggle one way or the other. And this SDI signal is going to go left or it's going to go right. Now, I think you can see that you could make this switch anything, So if you had something in your shack you wanted to turn on or off or control some kind of way, very easy to do. So we're going to talk a little bit about how we implemented this. And when I started on the project, I knew conceptually what I wanted to do, but I didn't know the particulars of how to actually get it done. Now, this you can do this with either a first generation Raspberry Pi or the latest. I did it with both, and the little SD card that I programmed, you can pull it out of a new one and put it in the old one. It runs just fine. This is not anything that requires massive amounts of processing or uber speed or anything like this. It's a very simple thing. Anyway, I'm showing here the Raspberry Pi 2 header, and you can see you have a number of GPIO, general purpose input outputs, that are available for use. And so we're going to pick some of those, and we're going to talk to them and tell it to go high or tell it to go low. This is a schematic of the little interface board I built. I used Eagle for it, and it was real simple to do. This is our GPI, this is our Raspberry Pi interface, and you can actually buy this socket. I think I got the socket from Mauser, and it was like, I don't know, 89 cents or something. It was dirt cheap. And this is another little socket up here. I thought for a while I wanted to put a real-time clock little module on because the Raspberry Pi doesn't have a real-time clock, but I ended up, I don't need it, so it was okay. Then this is nothing more than one chip with 6 buffers in it. It's not inverting or anything. It's just a buffer. And I added some little LEDs just so I could visually see what was going on, and brought it over to a little connection plug. Take DC in, and this is 12 volts out, and then this is 5 volts. And this, by the way, is the way Eagle shows the power connection to the IC. It's a little weird the way they do it. But bottom line is when you actually go and you make you do the board routing, all the pins line up where they're supposed to. Here's the relay board. This is our relay right here. This is our switch. This is the relay coil. This little transistor, you can put anything in here. I think I used 2N3904s or something. You could use a 2222. It doesn't draw any current. This guy is kind of important though. This takes care of, when the relay opens, it takes care of that pulse that gets generated from the coil. Yeah, the counter EMF. And then this is just a little LED so I could see, hey, I'm doing something, right? Because you can't really hear, at least I can't hear the relay click. And anyhow, I put two on a board, and they're just little boards is all. And then I make the connections to the relay with my SDI cable and number of common grounds. Very simple circuitry. Here's the actual board routing for the buffer board. Biggest thing on here other than the header is the fuse holder. So anyway, and here's the routing for the relay board. Here's where I make the connections with the 75 ohm cable, and I use that little miniature 75 ohm cable for that. There's no current that's on here. I mean, it's just data that's running around. So All right, the electronics are super simple. The whole project is in how to set up the Pi. And some of you guys might be Linux gurus. I'm not a Linux guru. I took a Linux class, and I don't remember much of it. And then at work we have one of our servers is running a Linux in a virtual machine, and another server is running Ubuntu server, and that's my Linux experience. It's not extensive, and I don't like Linux only from the standpoint that it seems like you have to fight with it too much. and I fought with this. But anyway, so how do you do it? So you buy a Raspberry Pi for $35, and it comes, and you get yourself a little, I was using a little 4 gig SD card, which is more than adequate. And you download and you install the operating system, and that's real easy. And the thing works after you download and install it on the SD card, and you put the SD card in the Raspberry Pi, and it boots up and it works. Well, the next thing that you're going to need to do is set a static IP, and that's because you want to be able to talk to this thing from the outside world. So you need a static IP inside on whatever your network is at home. The next thing I did was install and configure VNC, and I used TightVNC for this, and I've got some instructions for it. Sometimes the install works and sometimes the install doesn't work. VNC is a way of controlling your computer remotely. So it's like Microsoft Remote Desktop, but you can basically use it with any operating system. Anyhow, after that, I thought, well, I want to be able to, maybe pull a file off my Windows network. So then you have to install and configure Samba. That again is a pain in the tuchus. It's sometimes it works and sometimes it doesn't, but you'll get it to work. All right, so now you've got your Pi set up so that you can actually set it on a shelf somewhere and work remotely, from the comfort of your easy chair or whatever. Now, the next thing we have to do is we have to configure Python for the GPIO, and this is only a couple lines of code to do that. And Python is a programming language like BASIC or C or whatever. It's pretty simple to use. You can use it on Windows or Linux or doesn't matter. And there's a lot of support for it out there. And the Raspberry Pi has lots of stuff available written in Python for it. And I was surprised the other day. I had to install a software package from one of our video vendors, and the whole thing was written in Python. So it's you can do some very sophisticated stuff in it. Then the next thing you do is you configure Pi as a web server, and that again is real easy to do. A couple lines, Linux, and you install it. Then you need to write the code to communicate with the IOs, and I found some code that was almost exactly what I wanted, and I just had to putz around with it a little bit and change this and that, and that worked out really good, and that was done in Python. And then you have to enable port forwarding on your router, because you need to be able to talk from outside wherever over the internet and get to the Pi. And the Pi is going to be set up as a web server. And then finally, after you've got everything the way you want it, be sure you make a backup image, because these things are notorious for having little problems, and something doesn't work, and the easiest way to fix it is to just reflash your SD card with a known good code. So anyway, those were the steps I took. Now, setting the static IP is really easy. You are going to go sudo, which is super user. That's going to allow you to have the right rights or permissions to make these changes. And I'm using Nano because Nano comes with the Pi operating system, and it's a real simple little text editor. And then I put in the path to the interfaces file that holds the information about whether you're static or DHCP. So when you do this, then you're going to get a file, and it's going to say, the first couple lines are going to look like this, and it's going to say, this network adapter ETH0 is set up for DHCP. And that's what we have to change. And then it's going to have the rest of this here, which we won't concern ourselves with right now. And essentially, in the text editor, you're going to change DHCP to static, and then you're going to add these, you're going to add your address, your net mask, and your gateway, and this happens to be the address that was used in my particular case, except there should be another one there. But anyway, so all you have to do is run that, save the file, and then for you Windows guys, you know it's ipconfig, and that shows you what your IP address is. Well, in Linux it's ifconfig.
No.
And then it basically shows you the same thing, but it gives you actually a little more information about how your network is set up. It'll show your broadcast and so forth. The next step was install TightVNC. I'm just showing you the URL here that I used, and this did work for me. However, when I tried to use it with our Ubuntu server at work, it didn't work. So I had to Mickey Mouse around to get it to work. But this does work for the Raspberry Pi. And then once you've done that, you can VNC in, and this is what your screen is going to look like. So I took this picture from the comfort of my study, from the computer in my study, and the Pi is sitting down in the ham shack in the basement, and I can do anything that I want on the Pi right now. Now, the beautiful thing is I can even reboot it. And you're going to want to reboot from time to time, but whenever you reboot, then you lose your connection, and you have to enter your, open up VNC and reestablish the connection. Install Samba. Again, this is the URL that I used for the instructions, and that did work for me. And then this is a picture I think I took this one at my computer at work. But bottom line is here's our Pi share right here, and I can move files in and out using a Windows machine just fine. So if I want to, write some Python code or something, and I'm going to use Notepad Plus on my Windows machine, then I can save it and dump it in here and get it right into the Pi. Then we have to configure Python so that it can access the input outputs. And again, this is just a couple lines that at your Linux prompt you enter sudo Python, and then you get these three forward arrows, and you type in import rpi.gpio as GPIO, and hopefully it works. But if it doesn't work and you get an error, then you exit out and you say, okay, get the update, and then this is a general update, and then you say get the app and install Python rpi.gpio, and that installs it onto your Pi, and then you rerun this and you're good to go. And that's all done at the Linux prompt. Then we configure the Pi as a web server. And again, at the Linux prompt, you're going to do sudo apt-get install python -pip, followed by sudo pip install Flask. And Flask is actually our web server. You're done. It's configured as a web server now. And it's actually that simple. Now, you could write a regular HTML, page, hello world, right? Basically anything you can do in HTML for a web page you can do here. But this is the actual code that I ended up writing for the main landing page for this particular project I did. And what basically we're doing is we're calling up the Python code. And that's this right here. And I tried to put the 55 lines in PowerPoint, and it's like, nah. But if anybody actually wants this code, I'll be glad to forward you that code. It's 55 lines. It's pretty straightforward. A lot of it is redundant because we're calling 6 different GPIO ports, and there's a couple error things in there, and that's it. And I named it webswitch.py for Python. Then, from inside your network, your home network, you can call up and test this thing. And you don't need port forwarding for that. You just enter whatever the static IP is for your Raspberry Pi in your browser, and your page is going to come up. But if you want to do control from outside your shack, then you have to set up port forwarding. And so one of the things you need to know is what your public IP address is. Now, this is where most of us run into a little bit of a problem because we don't have static IPs at our home. We've got, either a cable modem from the cable company, or we've got DSL from the phone company, and they assign us a public IP, which is easy to determine what that is, but it can also change, right? So if you reboot your modem, you may likely get a new IP address.
So that they change it on you every other day or something.
They can, yeah. Although we have we have at work a static modem and a static IP and the associated modem, and then we also have another network with just a standard residential modem, and that IP has been the same for the past 6 months.
Oh, really?
So, and I know my IP at home does not change very often, but it does change occasionally. So anyway, how do you get around this? Well, you use a dynamic DNS service, and I use DYN. That's the service I use, and then you open the appropriate port. Well, you might ask, well, how do you do that, Steve? So here's my modem at home. I've got a NETGEAR, not modem, a router, and they're basically all about the same. Anyway, you're going to find an entry for something called dynamic DNS, and this brings up a page right here, and then you select your service provider. And in my case, it's www.dyndns.org, and I put my host name in, and my username and password, and I save it, and now my modem tells DYN what my public IP address is periodically. So I can access my internal machines using this service. I think it costs me $20 a year, something like that. It's nominal and makes life way easy. And then you just go into your port forwarding and you set it up. And that's about it. You're talking port 80 for this, but let's say you have a couple different machines and they're all configured as web servers. Well, then you're going to have to assign different ports to talk to, but you can do that. And now, hopefully, you've checked it, your little project from work or wherever, or from your smartphone, and everything's working, and then you make a backup image. And if you are going to make multiple copies, like say you want to have an image on a spare SD card, I would suggest that if you're using a 4 gig card, you stay with a 4 gig card. Because if you use an 8 or a 16 gig card, guess what? The next image that you make requires the full size of the card that you had used. And that's some error that I ran into. But anyway, in this case, everything fits on a 4G SD card, no problem, and I use Win32 as the program. It's shareware, and you back up the image, and then you can write the image to a new card. And it actually takes a while. It's like a 15-minute process to write it, read it, and write it. But then you've got everything squared away should your Raspberry Pi hiccup. And anyway, so this project at work, I completed it, I don't know, early summer, and the Pi just sits there in the server rack, runs 24/7, and it must have ran a good 4 months before I had to reboot it. So it's been pretty pretty reliable. So anyway, bottom line is, I wanted to share with you how I solved this one problem, right? And you can, I think you can see that there are a lot of applications you could use this concept for. You know, between simple on and off switching to something more elaborate. Sky's the limit.
So how did you set up the interface so the operators could use this setup on a daily basis?
All right, so on each of the machines in the 5 remote locations, I just created a bookmark to the URL, and basically, you know, I think we're coming in on port 8085 at work, I think is, you know, and they click on that bookmark, a real simple web page opens up, and that's from the HTML and the Python code, and then they have a click on or click off to turn the switch on or off, and it's really simple, and you can do it from your smartphone. John?
I'm not sure I'm understanding why you need an elaborate backup system. I mean, don't you just take the SD card, read it into a thumb drive, now you got your image? And later on you put on another equivalent SD card? I mean, it sounds like you're... you don't really do that with any file, right?
So basically, what I wanted was the complete image, and with Win32, I can read that image off, and I can save it to my desktop, or I can save it to thumb drive or whatever, and then just reverse the process. So yes, you're correct. It's very straightforward.
Are you wondering why the SD card's corrupt on the Raspberry Pi?
No, I'm just, like if I was doing basically you're trying to save what's ever on the SD card somewhere else so you can install it later on a new SD card or
Right.
I just wasn't understanding using this tool when File Manager or File Explorer does the same thing. It doesn't matter.
Linux file system's different than
That's the Linux one.
Windows.
And you're not looking for just the files, you're looking for the entire partition structure and the bootloaders and everything.
Yeah, that's fine.
Yeah, this ensures that you get a complete image. So that,
that's fine. It's more than just a file storage scheme.
Right.
Okay.
If you use SanDisk brand, for sure, some of the brands like Transcend and a few others, boy, you just breathe the wrong way and they'll corrupt. But SanDisk and then Class 10 SD cards, even if the power is lost, it won't corrupt the SD card. I've never lost one, but I know there are a lot of people that are having that problem out there.
We use the SanDisk Class 10s in our cameras at work, and we've had very good luck with them. And that's what I'm using here as well.
Yeah, you can go through the trouble of making the boot partition read-only and doing some other things, but you know, it doesn't seem to be all that necessary to do it, because you can put multiple partitions on an SD card and then set some read-only and then some read-write and go through all that hullabaloo. That's one of the known fixes for the corruption problem that's out there, but it seems like, again, people were using cheap, for lack of a better term, SD cards and having a lot of problems with them on the Raspberry Pi, you know, for that reason.
The time I had problems with the SD card was actually, I put it on a commercial roof in the middle of winter, and when it got cold, the pins were pulling away from the SD card, is the best I could guess, and it was causing voltage spikes and stuff, and the SD card actually was unusable even from a computer afterwards.
Right.
It was,
right, Yeah,
that's
they
like,
can
that's
brick.
hard to blend the card on it. It's
Yeah.
The new ones that have micro SD rather than SD, I think, do better at that. But
yeah, yeah,
if you're inside, that's not a
Yeah.
concern.
for sure.
So, that's all I've got. Anybody wants any of the source code or anything like that, just send me an email. I'll email it to you, and I can even provide you with an image that you would only have to go in and change your static IPs for. So, you know, if you want to send me a card, I can be glad to image that for you. It's a 4 gig file, so it's too big to, you know. But yeah, it was a fun project for me, and I'm going to continue on with this, you know, kind of train of thought for the ham shack. And $35. Oh, and one last final thing. Raspberry Pi just announced a new Raspberry Pi, $5. I don't think it has an Ethernet connection on it though. So
You can do Wi-Fi on there's 2 USB ports. One's on the go and one's for power. So if you go off of an adapter, because it's the same kind that I used on the SDR receiver we built last month. It's that mini A type. Then you can put a little USB Wi-Fi dongle on it. That's the current solution for that.
I heard they're almost impossible to find right now too.
They are.
Sold out really
Yeah, they're out of stock everywhere. So
What's out of stock?
the Raspberry Pi Zero.
Oh, the $5 one?
Yeah, they sold out in 4 hours.
Yeah, that one.
Yeah.
Yeah.
With nothing in sight when they're gonna be available again.
Right.
It probably won't be too long.
Nah.
It probably won't be $5 either.
I have a look, you probably find them on eBay for more than $5.
Oh yeah. Yeah. As a matter of fact, people are selling them on eBay for $50.
Oh,
It's when it came out.
Yeah. But
well, thanks guys.
that was very good, Steve. Thank you.
Did that all in one day.
No.
So,
And HTML stuff.
so did you write documentation for it, so if you're on vacation and your sub has to fix it?
That's it.
As a matter of fact, yes. It's in our instruction book, yeah. But it's pretty straightforward. Once you get it up and running, I don't want to call it bulletproof, but it's really simple circuitry.